All right, boy. So let's start this one. Complete the table, figure 11.1. Did you notice that all these questions are actually 11? Question by 11, question by 11, question by 11. Means the last question would be
Yeah.
from the nuclear. Yeah, the last question was from the nuclear part. So type of radiation, alpha radiations, they contain 2 protons, 2 neutrons. They carry positive charge. What about beta particles?
Beta particles are क्या कहते
The
हैं
nature,
negative
yeah.
electrons.
Very good, very good.
Electrons.
Electron, fast-moving electron. You'll write fast-moving electron. And this is
Yes.
charge?
But negative charge.
Negative charge. Gamma ray, nature. Quickly.
Nature, it has no proton, no
No, 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 no. You will write electromagnetic radiations.
energy. अच्छा, it's electromagnetic. Sir, ये मेरे दिमाग में आया था, आपने
कोई
पहले
बात
बोल
नहीं,
दिया.
कोई बात नहीं. Electromagnetic
Electromagnetic
radiations.
radiation
Yeah, and charge?
and no charge.
No
No,
charge. Good
none.
boy, good boy. You did it, boy. Acha ji. Explain what is meant by half-life. You know it. We just discussed, okay?
Hmm.
All right, next one.
Yes.
Explain why an isotope emitting gamma rays is used rather than an isotope emitting alpha particles. So we have to go through this one. It says Tactinium-99 is a relative isotope that emits gamma rays and it has a half-life of 6 hours. In a hospital, a solution containing this isotope is injected into a patient. The solution travels around the body and the isotope attaches to the cancer cells. A few hours after the injection, an instrument is used to detect the gamma rays emitted by the isotopes. A high reading on the instrument indicates the position of cancer cells. Okay.
Okay.
So what is happening actually? We have a patient, we have a cancer patient in the
I
hospital.
understand,
Okay, okay.
sir.
So the
Uh,
question is why
can
don't
I
we
say?
use
Mhm.
alpha? Okay, yeah, please.
Yeah. The reason why we don't use alpha is because it cannot penetrate through the skin, so it cannot won't be able to identify a tumor or a cancer cell, rather than gamma rays, which can penetrate not only through the body, but through it can penetrate even outside the body.
Very good.
Normally, alpha ray will be stopped by skin or even like a thin piece
Mm-hmm.
of paper,
Yes.
so it cannot
One,
detect.
one, one mark. You got 1 mark. Second.
Uh, okay, is used rather than isotope emitting alpha particles. And क्या कहते हैं सर, और क्या होगा?
Beta alphas are ionizing radiations.
Oh,
So they will ionize the
अच्छा.
blood cells, and that is dangerous. That is fatal for the patient. Patient can die, or can I mean, the tumor can increase, or cancer can increase, or I mean, become more unstable.
Oh,
So number one, alpha carries positive charge, highly ionized radiation, so they can create more problems. Number two, alpha being is less penetrating power, will not be possible for alpha to come out of the body and reach the detector. So will they stay in the body and will increase the cancer?
oh. Sir, ionizing. Can you further describe what that means?
Ionizing means ejecting out or emitting out the most loosely bounded electron from the outermost shell of an atom. किसी भी एटम के जो वैलेंस शेल होता है, आखिरी शेल जो होता है, उसमें से इलेक्ट्रॉन्स को निकालने का प्रोसेस इज कॉल्ड आयोनाइजेशन. एंड अल्फा being double positively charged have a very high tendency of ionization. ठीक है, so they are very strong ionizers. So if you inject alpha in the patient's body, so what happens is they cannot come out of the patient body, so they will stay in and will keep on ionizing the blood cells and the other cells in the body.
Oh,
Explain why using an isotope with a half-life of 6 hours is better than using an isotope with a half-life of 6 minutes.
okay. Huh? Explain why using an isotope with a half-life of 6 hours is better than using an isotope with a half-life of 6 minutes. Uh, uh, so that it can be given more time to find out the cancer cells.
Yeah, because if 6 minutes is a very short time, it's a very short interval of time. So what will happen? अभी आपने अपना इंस्ट्रूमेंट सेट ही नहीं किया, अभी पेशेंट की बॉडी में वो पूरा कंप्लीट सर्कुलेट ही नहीं हुआ, इससे पहले बॉडी रेडिएशन हाफ लाइफ आ जाएगा. ठीक है ना?
Hmm.
So it is not a good practice to use samples with a very short half-life, and also it is not a very good practice to use an isotope with a very long half-life. See here?
Yeah.
What it will do if you use it?
The radiation can become harmful to the body.
Yeah, it will remain in the
Which
body
can
for a longer time.
Mhm.
The
and
radiation will
can
remain.
yeah,
Yeah,
yeah.
obviously देखो देखो gamma radiations still radiations तो है ना,
Hmm.
radiations तो हैं.
Yes.
So if they are still in the body, so they can cause some problem.
Yeah, they can cause a lot of problems. They can even
Yeah.
increase your cancer.
जी 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 जी. Different radioactive isotopes used in hospitals has a half-life of 13 hours. A sample of this isotope and a detector are placed in a lead box. The count rate is recorded every minute for 3 minutes. The value obtained are 3203, 3140, and 53258 counts per minute. Explain why the three readings are not the same.
Because there are three different radiations.
नहीं 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 नहीं.
Okay.
या,
Uh,
याद रखिएगा, whenever excuse me, whenever you have this sort of fluctuation in the count rate, it shows the random nature of radiation, random nature.
nature of
Yeah,
radiation.
radioactivity, right? Random nature of
Yeah.
radioactivity, because emission is not like streamlined or smooth. Emission is random. Radioactive phenomena is random, right?
Yes.
Next one. Estimate the time taken for the average count rate to fall to 200 counts per minute.
Uh, a different
Estimate the time taken.
radioactivity.
Yeah, bolo shabash.
तो मैं सोच समझा 2 मिनट. सर,
Mhm.
हम लोग ऐसे कर सकते हैं, अगर ये वैल्यू 13 आवर्स में आई है तो ये वाली कितने में आएगी इन क्रॉस मल्टीप्लाई.
No, 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 not cross multiply. Actually, what you do first, what you will do, you will take an average of this. Do the average of this. Tell me what is the average
ओके.
coming.
ऑल हम लोग तीनों का ऐड कर देंगे, डिवाइड बाय 3 करेंगे,
Yeah,
राइट? बिकॉज
yeah, do
तीन
it, do it, do it. Tell me the answer.
3200.
3200 is the average count rates counts per minute. Okay.
Yes.
Now, you want it to reduce to 200. All right. So, simple formula, 3200 divided by 200. Tell me what is the answer coming? How much it is coming? 16, isn't it?
16. Yes.
16. So, it means it has covered n, then n by 2,
Yes.
then n by 4, then
Then
n
n
by
by
8,
16.
n
N
by
by 8, n by
16.
16. So
Yeah.
it's a 1, 2, 3, fourth half life.
Fourth half life. Fourth half
Yeah.
life. All right.
Yes.
So, fourth half life. What was the half life here? 13 hours.
13 hours.
So, time would be 4 half life, 4 into t half. That goes to 4 into 13 hours, 52 hours.
Yeah.
Right? Any problem?
No.
All right. So, अब आपको काफी हद तक समझ में आ गया how to do that.
Yes.
Now, can you do the rest of the question at your own?
I suppose so, yes.
शाबाश. अब आप क्या करें, घर पे पास पेपर खोलें, क्वेश्चन खुद अटेम्प्ट करें, and if you have query, send the query to me. I'll help you. Thanks for watching.